In this video, we're going to compute coefficient determination and correlation coefficient. We're continuing with the pizza parlor example. In the previous video on Excel, we generated this summary output for regression analysis, and we looked at the coefficients here, b sub 0 and b sub 1. So now let's look at the rest of the tables, not all of the information, but some of them that we need for coefficient determination. So first is sum of squares. Well, let's start from SST, sum of squares total. Okay, that information is in the ANOVA table. So total sum of squares is right there. So let's set this equal to that. And SSR is right here, sum of squares of regression, and SSE is that. Now R squared is SSR divided by SST. So SSR divided by SST. We can express this as a percentage also. Okay, let's make it into a percent. So what does it mean? Okay, interpretation for R squared is 90.3% of the total variability in the quarterly sales. Okay, so that's our Y response variable, and the variability in the response variable, 90.3% of it is explained by the regression between quarterly sales and size of student population. So this is how you must interpret coefficient determination. Now let's also look at the first table, and here there are several pieces of information that is displayed, of which one is R squared. Okay, we'll look at multiple R and adjusted R squareds later on. So this R squared is the same as what we found, as you can see. So we can get the R squared value from this table also. Okay, next is correlation coefficient. For correlation coefficient, we need to take a square root of this and assign the sign of the slope. So let's first set up the sign. And there is a function in Excel called sign, and the sign of the slope coefficient. So if slope coefficient is positive, you will get a +1. If the slope coefficient is negative, you will get a -1 for sign. So then we can take this sign multiplied by square root of R squared. So that will give us the correlation coefficient R. In the next video, we'll test for significance of the regression.